Alrighty, boundary value problem, example 4. Let's get right into it. Remember, this is y of x, both of these. This is number 17. Okay, let's look at this one first. So that has to be negative, right? So it looks like that. I can tell you right now, from the last problems, this becomes this. Remember, this is just a... Let me explain it. You plug this into here. Solve the characteristic equation. Well. So then this is C1. Oh, this one again. This one's going to be trivial. I already know. See, when you get good at this stuff, you can just kind of be able to tell. It makes your life a lot easier. Don't know what I did that for. Okay. Y prime of 0. Taking the derivative. Mu C1 e to the mu x plus minus, sorry. And we're plugging in 0, so that's 0, and that's 1, sorry. That's also 1. C1 equals C2. Just like the last two problems, we can rewrite it like that, and then we move on to the next boundary condition. Y of L equals 0 this time. That's the difference from the last problem. Is this condition? I can tell you right now this is trivial. E to the negative lambda x equals 0. You can pull out a C2. Now, remember, this right here has to be 0, but as you can see, it never is. It's always value. So no matter what here, we're always going to have a constant that is equal to 0. So we just say it's still C2 is equal to 0. So then that gives us y equals 0, which is trivial, which we don't want. So let's keep going. I can fit this right here. This should be a short one, because if that one's trivial, then this one definitely is. I can tell you right now, I just want to skip right to the thing. Let's go through it though. Repeated roots. Right? Check out my ODE videos for more clarification, or even my overview video. I went over it. Well, not over it, but y of 0, right? Prime. That's C2. Well, that's easy. So that's a possible. Well, it can't be because the other ones weren't constant. So I can tell you right now, this is trivial. But let's see. Is it of L, right? That's just C1 is 0. Yeah, that's trivial. Because C1 is 0, so Y is 0. Oh, well, it has to be the last one then. Look at that. How come we're getting so lucky? It's always the last one. I noticed that. I'm always picking them in the perfect order. Greater than 0. It has to be mu squared. complex, right? Mm-hmm. We have y prime of 0. Let me think. So this one becomes sine, goes to 0. This one becomes cosine, becomes 1. C2 is 0. Let's see. What's left? Y of L? Well, I forgot to rewrite this. This is clearly our eigenfunction, by the way. It's the only thing left that it has to be. C1 cosine mu L equals 0. Yeah, so let's, this is definitely non-trivial. Smiley face. So let's go ahead and, what makes this 0? Anything times pi, anything of pi, right? So I think so. No, that's sine. That's sine. This has to be the 1/2 pi. So, oh, the 1 minus 1/2. That's pi. Right? It has to be. I think so. Yes, it has to be. So now let's solve for mu. So you can see we have an interesting mu here, I guess. Fraction. Ew. Well, I guess there already was a fraction, even without the L. It just looks ugly now. And we gotta plug that in there. Okay. So our eigenvalue is mu squared. So we can write it like this. Whoops. I guess I could just square the whole term like the so. I'm gonna fix that real quick because it's bothering me. Okay. Sorry about my handwriting here. I'm going through these examples pretty fast. Eigenfunction y sub n is c sub n cosine of oh wait, times x, right? Yeah. Okay. There we go. Let me make sure that's right. Oh yeah, look. Wait, I have an or. Oh yeah. Oh look at. Oh, that's perfect. Okay. Yeah. You can also write. You can write this. Okay. Let me move this down. Forgot about that. I could have did this on the other ones too. You can rewrite this. Here. This can also be 2n minus 1 over 2 instead of 1 minus 1/2. Same thing. But you can rewrite your eigenfunction with that as well. As you can see, this would be 2n minus 1 over 2l, which is kind of simpler because you don't have this fraction here in the top. So like here, we can write it like this. This might be cleaner, I think. Yeah, this will definitely be cleaner because there's 2n minus 1 times pi x over 2l. Yeah, I would definitely write it like that. So. Wait, where did that n come from? This should be an n. This should be an n. What am I doing? 1 minus. I plugged in 1 for n. Oh my god. Good thing I caught that before I ended the video. Okay. Oh, did I just curse there on accident? But here is the, I think I'm getting tired. I still have, what, 2 examples left? Oh boy. Yeah, okay. So this is the answer. Not too bad, right? We got 2 more examples to go. See you in the next ones.